All right, today we're going to begin Chapter 5, looking at Section 5.1, which is going to deal with randomness, probability, and simulation. We're going to deal a lot with simulation this time, get them a little bit later in the chapter. But we'll start with just the general idea of probability. So when we talk about probability, it's a chance behavior of some kind. So chance behavior is unpredictable in the short run, but has a regular predictable pattern in the long run. So these are things you need to know. You need to know it's unpredictable in the short run, but that we can do a prediction in the long run, which is where a simulation is going to come in. So the definition of probability, it's an outcome of a chance process. It's always a number between 0 and 1. 0 meaning that it's never going to happen, 1 meaning it would always happen. Okay, that describes the proportion of times the outcome would occur in a very long series of repetitions. So meaning something that's happening many, many times that we're looking at. Okay, so that's our probability. So when we do probability, we're going to use simulation to help us a little bit. So sometimes probability situations do not lend themselves to an easy solution, or they're not something easy for us to do in real life over and over. So an acceptable approach is for us to run a simulation of some kind. So a simulation is going to be a procedure we're going to use to create a model that behaves like a real situation that we might not be able to do in real life. It's an imitation of our chance behavior based on a model that reflects whatever the situation is that we're dealing with. So when a simulation is run a large number of times, what we're going to do is collect the data, and then based on our experimental results, we will estimate a probability to be created. So in a simulation, we're going to use some type of random process to conduct numerous trials of the situation. So if this is done with a real statistical study, this would be done with some type of technology, usually on a computer of some kind, where they will let the simulation run for days or weeks, just many, many times. We're going to look at doing it by hand, so we're not going to really have a lot of numerous trials, but we are going to do some just so you can see how simulation works. And then we're going to count the number of successful outcomes to arrive at an estimated probability for our simulation that we're looking at. So when we do this, we have something called the law of large numbers. So the law of large numbers states that the proportion of successes in the simulation should become, over time, stable and close to the true proportion of a population. Again, the more trials, the closer and closer you come to the actual probability. So the graph here just kind of looks at if you were flipping a coin. When you flip a coin the first time, what's the probability you land on heads? Well, you flip it one time, it's either 1 or 0 because you do or don't. But over time, in a simulation, this is a simulation of looking at 100 flips of a coin, you can see how it evens out to 0.5 as we move on and on when you're looking at the average of how many times it happens that we land on heads. So some myths about randomness, some things that happen. Short run regularity, the idea that probability is a randomness is predictable in the long run, which means 1 million plus occurrences, which we're not going to do by hand. That's why we use technology. But probability does not allow us to make short run predictions. So for probability, we can only make predictions for a long run, something that's happening over and over. The law of averages myth is the probability tells us random behavior evens out in the long run. This is true. So future outcomes are not affected by past behavior. For example, think about a basketball player shooting a free throw. If I could have missed the last 50 that I shot, that doesn't mean I'm going to miss the next one. Okay, the past behavior does not make a difference. I still have a 50-50 shot of making that free throw. So future outcomes, what's going to happen next is not from my past behavior of my shooting. We might be able to make a prediction, but the outcome isn't going to change. So when we're performing a simulation, there are some things that we need to do, some steps, and you are going to be asked to do a lot of performing simulations. We'll deal with it more next class also. So here we're going to identify the probability calculation at interest. What is it we're trying to find? Why are we simulating it? What is the simulation? And what are we going to calculate at the end? Then we're going to plan. So when we plan, we have step 1. We're going to describe all possible outcomes. So whatever it is that we're looking at, how many outcomes do we have? If you were looking at shooting the basketball, you're either going to make it or you're going to miss it. Like, those are only 2 possible outcomes with what we're looking at. There could be more, it just depends on the situation. We're going to assign each possible outcome to 1 or more random numbers. So we're going to assign numbers similar to what we were doing in sampling. Okay, so assigning numbers sometimes can be a little more difficult. So we're going to look at some examples of assigning numbers. So suppose we want to choose a student at random from a group of which 70% participate in extracurricular activities. So when we look at this, The first thing you want to decide is, can I use a single digit? If you can use a single digit, you want to. It makes your life so much easier, but you can't always. Well, 70%, we could use a single digit on here because you can use a single digit of between 1 and 10 or 0 and 9 in our case to represent one person, okay, because you could pick 7 out of those 10 people. So in our case, we could let 1, 2, 3, 4, 5, 6, 7 equal student who participates in an extracurricular activity. And then 8, 9, and 0 would be students who do not. How you assign these is completely up to you. It's just something you have to lay out, because if you assign them differently than, say, I do in a simulation, we're going to get different answers, which is perfectly fine. You could say students 0 through 6 were participating in extracurricular activities and 7, 8, and 9 were not. It doesn't matter as long as you have 3 of them that don't and 7 of them that do. How you assign them after that is up to you. Here's another example. Suppose we want to choose a student at random from a group of which 32% participate in band. So with 32%, I'm not going to be able to use a single number. Okay, you'd have to have like your 60, 50, 70%, something that's a whole. So 32%, we're not going to be able to use a whole number, so we're going to have to use double digits, where each double digit simulates one person. So when we do our double digits, again, you would need to let like 0, 0 be 100, or else you would have to use triple digits, which we want to avoid using. We want to use as few digits as possible. Lots of different scenarios in this case. One of your scenarios could be that 01 through 32 is a student who participates in band, because that's 32 out of 100, 32%. Where 33 through 99 and 00, student who does not participate in band. You just as easily could have said that 00 through 31 participates in band and 32 through 99 does not. Again, many different ways that you can assign your numbers. As long as you have 32 that participate and the others that do not, then you will be fine when you're assigning your numbers. Okay, once we have our numbers assigned, we are going to step 3, which is a source of random numbers. So we've looked at sources of random numbers. We've looked at table D, which is our table of random digits. Okay, we've looked at our calculator with our RandInt, and then there's also computer software. There's Excel. If you Googled it, there's find all sorts of simulation things that you can use. Okay, so you would have to decide what source we're going to use to get our random digits. And then we're going to do in here. We're going to choose a random digit to replicate an outcome and record the outcome. We're going to perform many repetitions. And again, this could be hundreds or thousands of times until we get a stable pattern. So when we do it by hand, I'm going to tell you exactly how many you have. In real life, you would do it until you see a stable pattern. And then you're going to conclude. You're going to use the results of your simulation to analyze the simulated outcomes and report the results. We can now establish a probability based on what our simulation is. So when we're doing a simulation, some things that you want to consider. They sometimes require special consideration and use of your assigned random digits, and we've talked about this before. For example, what happens if we encounter the same random digit in our trial? Up to this point, we haven't wanted that to happen in our sampling, but in some situations, it's going to be acceptable, and other it's not. So you're going to have to make sure when you're explaining things that you state whether or not you can repeat a number or not, just depending on what the situation has. So we are going to look at an example right here. And our example that we're going to look at is, on average, how many calves would you expect Mama Cow to have if she had 3 calves? So again, this is on average, which means it's in the long run on what is happening. So we're going to go through the steps of running our simulation. So the first thing we want to do is state, what are we doing? We want to know how many calves would you expect Mama Cow to have if she had 3 calves on average. And we're going to find the average of our simulation then at the end, so we can figure out how many we think she should have. So when we do this, now we need a plan. So step 1 is list your possible outcomes. Well, our possible outcomes is Mama Cow is going to have a girl or she's going to have a boy. It just, one of those two things is going to happen. So in our case, you need to decide how you want to do your numbers. You can assign numbers any way you want to. In this situation, we're going to let even numbers be the girl and odd numbers be the boy. So in this case, our even is going to be 0, 2, 4, 6, and 8. Odd, 1, 3, 5, 7, and 9. 5 of each for 50-50, because we only have 2 outcomes, so there's a 50% chance of each in our 2 outcomes. And then we're going to say that we're going to use the random digit table provided, which in our case is going to be table D is what we're going to use. Most of the time, in this case, I'm giving you a random digit table right here to look at. So when you perform a simulation, you have to look at it. So we're saying mama cow is going to have 3 calves. So each number digit is going to represent 1 calf. So when we do this, if you're having 3 calves, we need to look at 3. So if we have 3 right here, 0, 3, and 5 would be 1 trial because she's going to have 3 calves. Of those 3 calves, you can see I have 1 even number and 2 odd. Odd were boys, even were girls. So number of girls, there was 1 in my first trial. So now my second trial is going to be my next 3 numbers, 0, 9, 0. So in that trial, number of girls was 2. Then in my third trial, 0, 1, and 4. So in this case, I have 2 girls again. My next trial is my groups of 3, 3, 3, and 6, so 1. My fifth trial, 7, 4, 9, 1. Then my sixth trial, 7, 7, 2, 1 again. My seventh trial, 7, 1, 9, we had 0. In my eighth trial, 9, 6, 7, 1. 5, 8, 2 for my next trial is 2. And then 7, 6, 1, I got 1 again. So that was my do. And when we do this, I'm going to start and I'm going to give you your random digit tables. I'm going to give you a table to fill in. I'm just going to say we did 10 trials in here. So 10 times that we looked at one experiment of mama cow having 3 calves. So now what we want to do is that was our do, we want to analyze. So we were looking on average how many she should have. So what we need to do is we need to find the average of our experiment. So if we look at our average, we're going to add up how many girls we had total right here. So if we add all that up, we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we did 10 trials, so 12 divided by 10, which means we would expect 1.2 girls, mama cow, to have 1.2. When you do this, it doesn't have to necessarily always be realistic. We know mama cow is not going to have part of a calf, but we would say on average we would expect 1.2. So you're going to have some multiple choice questions on sapling to answer, kind of looking at data, analyzing it, figuring out how many digits you need to have, and things like that. When we come back to class next time, we are going to work on performing some more of simulations like this, where we're going to do it over and over and see what happens. So your assignment today is 5-1 on sapling. I think it's like 15 or 16 questions for you to do on sapling. And then next class we will pick up and deal with some more simulation. If you have any questions, please let me know.